Good morning, students. Today's session is about the chemical reactions and equations related to the class 10th, the first chapter, that is chemical reactions and equations. This is your 10th first chapter from the science subject. So here we are going to study in this chapter. The main topics are what is meant by chemical reaction and how to recognize a chemical reaction taking place, and after this we'll study about the chemical equation and then we'll go for types of chemical and here will next part of this chapter is balancing chemical equations. After this we'll study about the types of reactions which comes under this chapter. And the last part of this chapter is corrosion and rancidity. So here we got the main topics of this chapter, that what we are going to study in this chapter. Here these all are the points that we are going to study in this chapter. We have to learn everything that are very important, and here the very important topic in this chapter is that the balancing chemical equations. It is very important to all the syllabus, that is related to CBSE, related to NCERT and related to state syllabus. So here we'll start with the chemical reaction in the today's session, and we'll complete one by one by learning all the things. Here now I'm going to start with chemical reaction. The definition of chemical reaction is that a chemical reaction, a change in which one or more substances react to form a new substance with entirely different properties. So it is known as a chemical reaction. I'm going to write the definition. So a chemical reaction is a change in which one or more substances react to form a new substance with entirely different properties. So as you all know, I written the definition of this chemical reaction here. A chemical reaction is a change in which one or more substances react to form a new substance with entirely different properties. Here what happens in a chemical reaction? In a chemical reaction, one or more substances, they are going to form or react with each other, and they are going to form a new substances that has entirely different properties. So this is the definition of chemical reaction. So next we are going to study that how the chemical reaction will take place and how to recognize, how to know that here a chemical reaction is taking place or not. Okay, so here Reacting substances are known as reactants. The reacting substances are known as reactants, and whatever the new substance formed, that is known as the product. So these are the very two important topics that you need to remember in the chemical reaction. That is, reacting substances are known as reactants, and the new substance which is formed by the reacting substances, that is called as product. Here we can see that the magnesium is going to react with oxygen and it is going to give the product as magnesium oxide, and here it is this side, means the LHS side of this we are called, these are the reactants and this is the product as we have seen on the upper side of that one. And here a magnesium and oxygen, they are going to react and they are going to form the magnesium oxide. How we are going to say that the chemical reaction has taken place? So that is we are going to study now, that how, on what basis we are going to tell that the chemical reaction has been taken place or not. So now we'll study about the factors, that how we are going to confirm a chemical reaction is taking place. Okay, here you can see that chemical reaction has taken place or not, means we have to go for these characteristics of that chemical reactions. It should be change in state or change in color, evolution of gas, change in temperature, formation of a precipitate. These are the very important conditions that these will give us the confirmation of a chemical reaction as taking place or not. If a reaction, in a reaction, it's changing its state, then we are going to say that a chemical reaction has taken place. And change in color, then also we can say that. And evolution of a gas, then also we can confirm that the chemical reaction is taking place. These are the very important roles that we are going to know when we need to know about the chemical reaction is taking place. So these are the very important things, that change in state, change in color, evolution of a gas, change in temperature, formation of a precipitate. So after this we are going to study that how to write a chemical equation, because we are knowing about the chemical reactions. If a chemical reaction is taking place, means we have to show that. How to show that chemical reaction, that we will study now. Here the second topic of this chapter is chemical equations. Chemical equation is nothing but the symbolic representation of the chemical reaction. So here it is nothing but symbolic representation of chemical reaction. So chemical equation means that symbolic representation of a chemical reaction, very easy to understand. And here what is the symbolic representation? Means already we studied about the magnesium ribbon. Now itself we studied that about magnesium ribbon. How we are going to say that a reaction is taking place? So here magnesium ribbon is going to react with oxygen and it is going to form magnesium oxide. So I told in the sentence form, so it is very long to explain. For that we have to use a short form, that we can write that reaction in word form, like magnesium is going to react with oxygen. This is an example for this chemical equations. Here we are going to get magnesium oxide. So Already we studied in sentence form. Sentence form is very long to write in the exam, and it is the word form. Now we written in the word form. We can see that, can we write in the shortest way? Another shortest way? Yes, we can write it in the shortest way, that by using the symbol of magnesium, symbol of oxygen, and we are going to get that symbol of magnesium oxide. So how we have to write that one? Very easy thing, that the symbol of that magnesium is Mg and the oxygen is that O2, and we are going to get that MgO, means magnesium oxide. Here we can see that the two substances are going to react with each other and they are going to form a new substance with entirely new properties. Okay, so they are having a different properties than that the products as well. See, these things we are going to call them as reactants, and here we are going to call it as product. Here in the chemical equations, these are the very important things that we need to follow, that how to write a chemical equation and how to represent them in a symbolic form. So it is very easy, that we have written already that magnesium is going to react with oxygen and it is going to form magnesium oxide. So we can see that it is very easier than the word form. This is symbolic form. You can see that a symbolic form is very easy to write a chemical reaction in a very easy format, and we can conclude that here the chemical reaction is taking place, and the reactants always will be left hand side and the product will always be on the right hand side. So LHS and RHS. In between the substances which are reacting together, we have to write positive sign, and in between the two, in between them means the reactants and products. In between the reactants and products, we have to show the arrow mark. We have to write in between the substances the positive sign, and in between the product and reactants, we are going to write the arrow mark. So left hand side of the arrow mark will be the reactants, and right hand side of the arrow mark will be the product side, and the product side it is going to represented by the RHS, and here it is by the LHS. So these are the reactants and these are the products. So another example I am going to give you. See here, a methane. Methane is going to react with oxygen, and what it is going to form? You are going to see that carbon dioxide with water. So this is the word form of chemical equation. We have to write it in the symbolic form, that is methane. Already you know the formula of that methane, that is CH4, and oxygen it is O2. It is going to form carbon dioxide formula. Already you know that CO2 and H2O. So here we got this much as the result, that these two are the reactants. Again we are going to study that also, and these two are the products. So product side will be the RHS and reactant side will be the LHS. So here we can say that methane is CH4 and oxygen is O2, and then carbon dioxide is CO2, and then H2O is the water. Already you know these things, and after this we'll study about the balancing of the chemical equations. Before going to the balancing of chemical equations, some defects are there in this reaction that we will conclude by studying that one. Here the chemical reaction has taken place and we have written in the chemical equation form by using the symbolic representation. So here what happening, both the side the elements are same one thing, and the second thing is that they are balanced or unbalanced. If they are balanced equation, then it is okay. If they are not balanced, they are called unbalanced chemical equation or skeletal chemical equation will be there. Okay, so here we can see that LHS side and RHS side we have same elements that are carbon, hydrogen and oxygen. So here we can see that carbon is 1 and that side also 1, and hydrogen is at LHS side it is 4 and RHS side 2, and oxygen 2 at the LHS side and 3 at the RHS side. So here we can say that these LHS and RHS sides are not equal. So the unequal sides of the reactions are going to call, or this reaction we are going to call it as skeletal chemical equation. Skeletal chemical equation. Okay, or we can say it as or unbalanced chemical equation. Why we are saying unbalanced? Already you know the thing that they are not same at the both LHS and RHS side. We are going to balance this reaction by using the balancing method that is there. Okay, we'll study about that balancing of chemical equation now. So now we are going to study the balanced chemical equation. A balanced chemical equation is directly depending on the law of conservation of mass. According to this law, here mass neither be created nor be destroyed in a chemical reaction. So that you need to understand, because already we have studied in 9th class that laws of conservation of mass. Here I am going to give you an example of this balanced chemical equations. Here zinc is going to react with sulfuric acid and it is going to form zinc sulfate with that hydrogen. So here we can see that zinc symbol is Zn and sulfuric acid it is H2SO4, and it is going to form zinc sulfate ZnSO4 with that hydrogen gas. Let's check whether this reaction is balanced or unbalanced. Already you know that unbalanced chemical equations is also known as skeletal chemical equations. So let's see that by putting this LHS and RHS elements, that first element is, so elements, first element is zinc, second element is hydrogen, third is sulfur, and fourth one it is oxygen. So zinc in the left hand side it will be 1 and right hand side also it will be 1, and hydrogen in the left hand side 2 hydrogens are there, and in the right hand side also we have 2 hydrogens. What about the sulfur? Sulfur also 1 and that side also 1. We can see that oxygen has 4 element and oxygen is also having 4 element in the right hand side and left hand side. We can see that both the sides, left hand side as well as right hand side, both are in the equal form. So we can say that this reaction is balanced chemical equation. So this equation we can say that it is completely balanced equation. So next example I am going to give you the last reaction which we have studied already, that magnesium ripple. See, magnesium is going to react with oxygen and it is going to form magnesium oxide. Here again we'll write that table elements LHS, RHS. Here you can see that magnesium and oxygen, only two elements are there. The first element is magnesium. We'll write that left hand side one magnesium is there and right hand side it is also one element, and the second one, that is oxygen, in the left hand side two oxygens are there, but right hand side only one oxygen is there. So the first element is balanced, so we can't say that it is unbalanced because it is already balanced. We'll go for the second element, that is oxygen. Oxygen is 2 in the left hand side and 1 in the right hand side, so we have to balance at the right hand side by taking the numbers of that elements. See here, Mg plus O2, and here how to write that, how many elements we need here? Oxygen, here it is 2, means this side also we need 2 elements of oxygen, but here it is having only 1. Can we take 1 here? No, it is not possible. And can we take, or can we label the balancing here? We can't balance here also, and here we can't balance here also. Uppercase, lowercase, and in the back side of that element it is also not possible. So here we have to balance oxygen, means we need to take the number of elements here itself. So like it is 2 magnesium oxide, means here if we have to balance oxygen, means we have to take the numbers behind of that products, So here we got that magnesium oxide, and here we can remove 1 and we can put 2 because oxygen is balanced now. This side also 2 and that side also 2. But what about the magnesium? Magnesium is at the left hand side, it is 1, but the right hand side it became 2. So what we have to do this situation, how to handle this situation? Again we have to handle that. How to handle means, again we have to take the numbers, means here in the left hand side the minimum number is 1, so we have to make it as 2, then only it will become the same in the both the sides. So this is what the balancing of equation, that magnesium element it has LHS2 and RHS2, and oxygen is also LHS2 and RHS2. Now we can say that this is balanced equation. We can say now it as balanced equation, and here we can say it as the unbalanced chemical equation. We can say it as unbalanced chemical equation because here the elements are not in a balanced form, but here we can say that the elements are same in the both the sides, as well, in the left hand side as well as in the right hand side. So this is very important for your point of examination because it includes 3 marks. The balancing of equation which includes 3 marks, and it is very important, and also it is very easy to write and very easy to balance. If you learn this method, means you are very lucky that you will get 3 marks. Confirm 3 marks you are going to get from this topic. It is very important topic from the first chapter. Already I told in the beginning of this session, the balancing chemical equation is very important to point of view of your exam. It is very important, so keep it in mind that learn very easily that how to write a chemical equation and how to balance a chemical equation. This will give you very easy method that I told you peoples, so learn well. Okay, so next topic is that the types of chemical reactions. So next topic of this chapter is that types of chemical reactions. Already in 9th class we have learned that in a chemical reactions elements are not going to change into another element, but they are going to reshuffle, means they are going to convert into another product to form a new product. That is, one element is going to react with another element, and in the product side also the same elements will be there, because already in 9th class that we all studied that there is only exchange of elements to produce a new product, to form a new product. Here there are 5 types of chemical reactions are there. In that first one, it is combination reaction. Second one, it is decomposition reaction. And third reaction is that displacement reaction. Fourth one, double displacement reaction. And fifth type of reaction is that redox reaction. We can call this redox reaction is also written as oxidation and reduction reaction. So in a combined form we can say it as a redox reaction. So these are the types of chemical reactions. So in that first one, it is chemical combination reaction, decomposition reaction, displacement reaction, double displacement reaction, redox reaction. We can also know known as oxidation and reduction reactions. So here in this class we are going to study one by one reactions and their examples and what is mean by combination reaction and their definitions. These all will include in this today's class. So here we'll go first for the combination reaction. The definition of combination reaction is nothing but a chemical reaction. It is a type of a chemical reaction in which one or more substances are going to react to form a single substance. So here, what is the definition of combination reaction means? In which reaction one or more substances are going to react with each to form a single product. So this is the definition of combination reaction, is that when in which reaction one or more substances are going to react with each other and they are going to form a single product. It is known as combination reaction. Here, for example of this one, we can see that magnesium is going to react with oxygen. It is going to form a magnesium oxide. Here it is a perfect reaction for this combination reaction. Also, we need to know basically that A is going to react with B and they are going to form AB. So this is the combination reaction. It is very easy reaction that we need to remember, in which reaction one or more substances are going to react with each other to form a single product. In which reaction? That is in a combination reaction. The combination reaction. Combination means what? Combining. Combination means what? combining together to form a single product. That is very easy definition of this combination reaction, and we have to give the easy example also. We can remember, that is magnesium is going to react with oxygen and it is going to form magnesium oxide. So, and also we can remember by doing the basic things that A plus B is going to give you the AB. The combination reaction, we can give many types of examples, that burning of coal. Burning of coal. See here, carbon is going to react with oxygen and it is going to form carbon dioxide. So here burning of coal is also an example of the combination reaction. And another one example is that formation of water molecule, that hydrogen, formation of water. How we are going to form the water? That by hydrogen and oxygen, they are going to give you that H2O. By balancing, we can write like this, so it will become this one. And here we can say that here hydrogen and oxygen are combining to form water. Here it is oxygen and hydrogen. Hydrogen and oxygen, they are going to combine together to form water molecule. This is also a combination reaction example. And the burning of coal, when carbon is going to react with or burn in the air, by the reaction of that one also we can say that carbon dioxide is also a example of combination reaction. So these are the examples that we got on the basis of the combination reaction.